Hey guys, so in this video I'm going to be talking about converting recurring decimals into fractions. We'll start off with a basic example. So when you're turning recurring decimals into a fraction, you can use this really useful trick. It just makes the whole process very simple. If we start with the example of 0.234 recurring, having the 2, 3, 4 as a recurring sequence, what you would do is first you'd essentially name this decimal. In this case, we're going to name it r. And then next, what you're going to do is you're going to multiply r by a power of 10 that moves this recurring sequence past the decimal point. So we want to move these numbers over 3 spaces. For us to do that, we have to do 10 to the power 3, which is 1,000. So we're timesing r by 1,000. So when we do r times 1,000, we get 1,000 r. 0.234 recurring times by 1,000 is 234.234 recurring. Cool. So now all you need to do is take away r from 1000 r. What this is going to do is terminate the repeating sequences. So if we just do the calculation, 1000 r, which equals 234.234 recurring, minus r, which equals 0.234 recurring. We're left with 999r, which equals 234. Now all that's left is we have to rearrange the equation to find 1r. The way we could do that is divide left and right side of the equal sign by 999. This will give us r equals 234 over 999. Now this isn't quite done. Even though this fraction does represent this recurring decimal here, it's not quite in the simplest form. So what we want to do is simplify it. So find common factors between 234 and 999. First one that comes to mind is 3. When we divide top and bottom by 3, we get 78 over 333. But 78 and 333 also have common factors, that common factor being 3. So divide top and bottom by 3 again, we're left with 26 over 111. So 26 over 111, that is your answer. That's your final answer. Now this method is a bit long-winded, and even though in exams they may expect you to go through these stages to get the marks, it's actually a shortcut to finding out what the fraction will look like for a recurring decimal. So if we go back to 0.234 recurring and look at the recurring unit, I just use that as the numerator for our fraction. The denominator will just be made up of 9s, but the number of 9s will be determined by how many numbers are actually in this recurring sequence. In this case there are 3, so they're going to be 3 9s. So the denominator will be 999. That's the answer we had before, but you'd still need to simplify it. If we look at the case of 0.23 recurring, you follow the same kind of method. So you just do 23 over 99. If we had 0.57216, again, follow the same method. So we write 57216 as the numerator, and the denominator will have 5 9s because there are 5 numbers in the repeating unit. That would be your answer. But then again, these still have to be simplified. Keep in mind though that this method only works if the repeating unit is immediately after the decimal point. Otherwise you need to use slightly different tricks. Let's go with a slightly trickier example. If we were given the example of 0.16 recurring with the recurring unit just being the 6, you start off the same as the previous method. First you're going to name this 0.16 recurring, so let's name it r. But the next steps are slightly different. Step 2 would be multiplying r by a power of 10 to move the non-repeating part, the 1, past the decimal point. In this case we only need to times it by 10. So r times 10 is 10r. So 10r equals 1.6 recurring. Third step, we want to multiply r again to move 1 full repeating lump past the decimal point. Now the repeating lumps here are 6s, so we just need to move 1 6 across the decimal point. So again, 10r, we need to times that by 10. That would leave us with 100r, which equals 16.6 recurring. From here, the steps look pretty similar to the previous examples. You have 100r, which equals 16.6 recurring, minus 10r, which equals 1.6 recurring. And this recurring unit here should cancel out, leaving us with essentially 16 minus 1. So 90r equals 15. If you want to change this expression to find 1r, we have to divide left and right side of the equal sign by 90, giving us 15 over 90, which then simplifies to 1 over 6. 15 and 90 both have common factors of 15, so divide top and bottom by 15, we get 1 over 6. Great. Here's some other examples you can try out. If you found this video helpful, please like the video and subscribe to the channel so that way you can be updated when I upload a new video. Bye guys.